Chapter 2 of Islands of Space by John W. Campbell. This LibriVox recording is in the public domain. Islands of Space. Chapter 2. The many books and papers they had collected were hastily put into the briefcases, and the four men took the elevator to the landing area on the roof. "We'll take my car," Maury said. "The rest of you can just leave yours here. They'll be safe for a few days." They all piled in as Maury slid into the driver's seat and turned on the power. They rose slowly, looking below them at the traffic of the great city. New York had long since abandoned her rivers as trade routes. They had been covered solidly by steel decks, which were used as public landing fields and groundcar routes. Around them loomed titanic structures of glistening colored tile. The sunlight reflected brilliantly from them, and the contrasting colors of the buildings seemed to blend together into a great, multicolored painting. The darting planes, the traffic of commerce down between the great buildings, and the pleasure cars above combined to give a series of changing, darting shadows that wove a flickering pattern over the city. The long lines of ships coming in from Chicago, London, Buenos Aires, and San Francisco, and the constant flow from across the pole, from Russia, India, and China, were like mighty black serpents that wound their way into the city. Maury cut into a northbound traffic level, moved into the high-speed lane, and eased in on the accelerator. He held to the traffic pattern for 250 miles, until he was well past Boston. Then he turned at the first break and fired the ship toward their goal in Vermont. Less than 45 minutes since they had left New York, Maury was dropping the car toward the little mountain lake that offered them a place for seclusion. Gently, he let the ship glide smoothly into the shed where the first molecular motion ship had been built. Arcot jumped out, saying, "We're here. Unload and get going. I think a swim and some sleep is in order before we start work on this ship. We can begin tomorrow." He looked approvingly at the clear blue water of the little lake. Wade climbed out and pushed Arcot to one side. "All right, out of the way then, little one, and let a man get going." He headed for the house with the briefcases. Arcot was 6'2" and weighed close to 200. But Wade was another 2 inches taller and weighed a good 50 pounds more. His arms and chest were built on the same general plan as those of a gorilla. He had good reason to call Arcot little. Maury, though still taller, was not as heavily formed, and weighed only a few pounds more than Arcot, while Fuller was a bit smaller than Arcot. Due to several factors, the size of the average human being had been steadily increasing for several centuries. Only Wade would have been considered a big man by the average person, for the average man was over 6 feet tall. They relaxed most of the afternoon, swimming and indulging in a few wrestling matches. At wrestling, Wade consistently proved himself not only built like a gorilla, but muscled like one. But Arcot proved that skill was not without merit several times, for he had found that if he could make the match last more than 2 minutes, Wade's huge muscles would find an insufficient oxygen supply and tire quickly. That evening, after dinner, Maury engaged Wade in a fierce battle of chess, with Fuller as an interested spectator. Arcot, too, was watching, but he was saying nothing. After several minutes of uneventful play, Maury stopped suddenly and glared at the board. "Now, why'd I make that move? I intended to move my queen over there to check your king on the red diagonal." "Yeah," replied Wade gloomily, "that's what I wanted you to do. I had a sure checkmate in 3 moves." Arcot smiled quietly. They continued play for several moves, then it was Wade who remarked that something seemed to be influencing his play. "I intended to trade queens. I'm glad I didn't, though. I think this leaves me in a better position." "It sure does," agreed Maury. I was due to clean up on the queen trade. You surprise me, too. You usually go in for trades. I'm afraid my position is hopeless now." It was. In the next 10 moves, Wade spotted the weak points in every attack Maury made. The attack crumbled disastrously, and White was forced to resign, his king in a hopeless position. Wade rubbed his chin. "You know, Maury, I seem to know exactly why you made every move, and I saw every possibility involved." "Yeah, so I noticed," said Maury with a grin. "Come on, Maury, let's try a game," said Fuller, sliding into the chair Wade had vacated. Although ordinarily equally matched with Fuller, Maury again went down to disastrous defeat in an amazingly short time. It almost seemed as if Fuller could anticipate every move. "Brother, am I off form today," he said, rising from the table. "Come on, Arcot, let's see you try Wade." Arcot sat down, and although he had never played chess as extensively as the others, he proceeded to clean Wade out lock, stock, and barrel. "Now what's come over you?" asked Maury in astonishment, as he saw a very complicated formation working out, a formation he knew was far better than Arcot's usual game. He had just worked it out and felt very proud of it. Arcot looked at him and smiled. "That's the answer, Maury." Maury blinked. "What? What's the answer to what?" "Yes, I meant it. Don't be so surprised. You've seen it done before. I have. No, not under him, but a more experienced teacher. I figured it would come in handy in our explorations." Maury's face grew more and more astonished as Arcot's strange monologue continued. Finally, Arcot turned to Wade, who was looking at him and Maury in wide-eyed wonder. And this time it was Wade who began talking in a monologue. "You did?" he said in a surprised voice. "When?" There was a long pause, during which Arcot stared at Wade with such intensity that Fuller began to understand what was happening. "Well," said Wade, "if you've learned the trick so thoroughly, try it out. Let's see you project your thoughts. Go ahead." Fuller, now understanding fully what was going on, burst out laughing. "He has been projecting his thoughts. He hasn't said a word to you." Then he looked at Arcot. "As a matter of fact, you've said so little that I don't know how you pulled this telepathic stunt, though I'm quite convinced that you did." "I spent 3 months on Venus a while back," said Arcot, "studying with one of their foremost telepathists. Actually, most of that time was spent on theory. Learning how to do it isn't a difficult proposition. It just takes practice. The whole secret is that everyone has the power. It's a very ancient power in the human brain, and most of the lower animals possess it to a greater degree than do humans. When man developed language, it gave his thoughts more concreteness and permitted a freer and more clearly conceived type of thinking. The result was that telepathy fell into disuse. I'm going to show you how to do it, because it will be invaluable if we meet a strange race. By projecting pictures and concepts, you can dispense with going to the trouble of learning the language. After you learn the basics, all you'll need is practice, but watch yourself. Too much practice can give you the great granddaddy of all headaches. Okay, now to begin with." Arcot spent the rest of the evening teaching them the Venerian system of telepathy. They all rose at 9. Arcot got up first, and the others found it expedient to follow his example shortly thereafter. He had brought a large Tesla coil into the bedroom from the lab, and succeeded in inducing sufficient voltage in the bed springs to make very effective, though harmless, sparks. "Come on, boys, hit the deck. Wade, as chief chemist, you are to synthesize a little coffee and heat-treat a few eggs for us. We have work ahead today. Rise and shine!" He didn't shut off the coil until he was assured that each of them had gotten a considerable distance from his bed. "Ouch!" yelled Maury. "Okay, shut it off. I want to get my pants. We're all up. You win." After breakfast, they all went into the room they used as a calculating room. They had 2 different types of intergraph calculators and plenty of paper and equipment to do their own calculations and draw graphs. "To begin with," said Fuller, "let's decide what shape we want to use. As a designer, I'd like to point out that a sphere is the strongest, a cube easiest to build, and a torpedo shape the most efficient aerodynamically. However, we intend to use it in space, not air. And remember, we'll need it more as a home than as a ship during the greater part of the trip." "We might need an aerodynamically stable hull," Wade interjected. "It came in mighty handy on Venus. They're darned useful in emergencies. What do you think, Arcot?" "I favor the torpedo shape. Okay, now we've got a hull. How about some engines to run it? Let's get those too. I'll name the general things first. Facts and figures can come later. First, we must have a powerful mass-energy converter. We could use the cavity radiator and use cosmic rays to warm it, and drive the individual power units that way. Or we can have a main electrical power unit and warm them all electrically. Now, which one would be better?" Maury frowned. "I think we'd be safer if we didn't depend on any one plant, but had each as separate as possible. I'm for the individual cavity radiators." "Question," interjected Fuller. "How do these cavity radiators work?" "They're built like a thermos bottle," Arcot explained. "The inner shell will be of rough relux, which will absorb the heat efficiently, while the outer one will be of polished relux to keep the radiation inside. Between the two will run a flow of helium at 2 tons per square inch pressure to carry the heat to the molecular motion apparatus. The neck of the bottle will contain the atomic generator." Fuller still looked puzzled. "See here, with this new space strain drive, why do we have to have the molecular drive at all?" "To move around near a heavy mass, in the presence of a strong gravitational field," Arcot said. "A gravitational field tends to warp space in such a way that the velocity of light is lower in its presence. Our drive tries to warp or strain space in the opposite manner. The two would simply cancel each other out, and we'd waste a lot of power going nowhere. As a matter of fact, the gravitational field of the Sun is so intense that we'll have to go out beyond the orbit of Pluto before we can use the space strain drive effectively." "I catch," said Fuller. "Now, to get back to the generators. I think the power units would be simpler if they were controlled from one electrical power source, and just as reliable. Anyway, the molecular motion power is controlled, of necessity, from a single generator, so if one is apt to go bad, the other is too." "Very good reasoning," smiled Maury. "But I'm still strong for decentralization. I suggest a compromise. We can have the main power unit and the main verticals, which will be the largest, controlled by the individual cosmic ray heaters, and the rest run by electrical power units. They'd be just heating coils surrounded by the field." "A good idea," said Arcot. "I'm in favor of the compromise. Okay, Fuller? Okay. Now, the next problem is weapons. I suggest we use a separate control panel and a separate generating panel for the power tubes we'll want in the molecular beam projectors." The molecular beam projector simply projected the field that caused molecular motion to take place as wanted. As weapons, they were terrifically deadly. If half a mountain is suddenly thrown into the air because all the random motion of its molecules becomes concentrated in one direction, it becomes a difficult projectile to fight. Or touch the bow of a ship with the beam, the bow drops to absolute zero and is driven back on the stern, with all the speed of its billions of molecules. The general effect is similar to that produced by two ships having a head-on collision at 10 miles per second. Anything touched by the beam is broken by its own molecules, twisted by its own strength, and crushed by its own toughness. Nothing can resist it. My idea, Arcot went on, was that since the same power is used for both the beams and the drive, we'll have two separate power tube banks to generate it. That way, if one breaks down, we can switch to the other. We can even use both at once on the drive if necessary. The molecular motion machines will stand it if we make them of relux and anchor them with lux metal beams. The projectors will be able to handle the power, too, using Dad's new system. That will give us more protection, and at the same time full power. Since we'll have several projectors, the power needed to operate the ship will be about equal to the power required to operate the projectors. And I also suggest we mount some heat beam projectors. "Why?" objected Wade. "They're less effective than the molecular rays. The molecular beams are instantly irresistible, while the heat beams take time to heat up the target. Sure, they're unhealthy to deal with, but no more so than the molecular beam." "True enough," Arcot agreed, "but the heat beam is more spectacular. And we may find that a mere spectacular display will accomplish as much as actual destruction. Besides, the heat beams are more local in effect. If we want to kill an enemy and spare his captive, we want a beam that will be deadly where it hits, not for 50 yards around." "Hold it a second," said Fuller wearily. "Now it's heat beams. Don't you guys think you ought to explain a little bit to the poor old goon who's designing this flying battle wagon? How did you get a heat beam?" Arcot grinned. "Simple. We use a small atomic cavity radiator, at one end of which is a rough relux parabolic filter. Beyond that is a lux metal lens. The relux heats up tremendously, and since there is no polished relux to reflect it back, the heat is radiated out through the lux metal lens as a powerful heat beam." "Okay, fine," said Fuller, "but stop springing new gadgets on me, will you?" "I'll try not to," Arcot laughed. "Anyway, let's get on to the main power plant. Remember that our condenser coil is a gadget for storing energy in space. We are therefore obliged to supply it with energy to store. Just forming the drive field alone will require 2 × 10⁻27 ergs, or the energy of about 2.5 tons of matter. That means a whale of a lot of lead wire will have to be fed into our conversion generators. It would take several hours to charge the coils. We better have 2 big chargers to do the job. The controls we can figure out later. How about it? Any suggestions?" "Sounds okay to me," said Morey, and the others agreed. "Good enough. Now, as far as air and water go, we can use the standard spacecraft apparatus, Fuller, so you can figure that in any way you want to." "We'll need a lab, too," Wade put in, "and a machine shop with plenty of spare parts, everything we can possibly think of. Remember, we may want to build some things out in space." "Right. And I wonder—" Arcot looked thoughtful. "How about the invisibility apparatus? It may prove useful, and it won't cost much. Let's put that in, too." The apparatus he mentioned was simply a high-frequency oscillator tube of extreme power, which caused vibrations approaching light frequency to be set up in the molecules of the ship. As a result, the ship became transparent, since light could easily pass through the vibrating molecules. There was only one difficulty. The ship was invisible, all right, but it became a radio sender and could easily be detected by a directional radio. However, if the secret were unknown, it was a very effective method of disappearing. And since the frequency was so high, a special detector was required to pick it up. "Is that all you need?" asked Fuller. "Nope," said Arcot, leaning back in his chair. "Now comes the kicker. I suggest that we make the hull of foot-thick lux metal, and line it on the inside with relux wherever we want it to be opaque. And we want relux shutters on the windows. Lux is too doggone transparent. If we came too close to a hot star, we'd be badly burned." Fuller looked almost goggle-eyed. "A foot of lux? Good Lord, Arcot! This ship would weigh 250,000 tons! That stuff is dense!" "Sure," agreed Arcot, "but we'll need the protection. With a ship like that, you could run through a planetoid without hurting the hull. We'll make the relux inner wall about an inch thick, with a vacuum between them for protection in a warm atmosphere. And if some tremendous force did manage to crack the outer wall, we wouldn't be left without protection." "Okay, you're the boss," Fuller said resignedly. "It's going to have to be a big ship, though. I figure a length of about 200 feet, and a diameter of around 30 feet. The interior I'll furnish with aluminum. It'll be cheaper and lighter." "How about an observatory?" "Put it in the rear of the ship," Wade suggested. "We'll mount one of the Nigrant electroscopes." "Control room in the bow, of course," Morey chipped in. "I've got you," Fuller said. "I'll work the thing out and give you a cost estimate and drawings." "Fine," said Arcot, standing up. "Meanwhile, the rest of us will work out our little exhibition to impress Mr. Morey and Dad. Come on, lads, let's get back to the lab." End of Chapter 2.